Welcome back to another chemistry tutorial from me, Miss T, a qualified teacher, Oxford University graduate, and your friendly neighborhood online tutor. This video works through calculating mass from moles and vice versa, with of course some worked examples and questions for you to try at the end. So a reminder from our last video, a mole is a measurement of the amount of substance and consists of 6.02 times 10 to the 23 particles. For a full lesson on moles, go back to my very first video. In reality, of course, we don't count individual particles. We'll typically be dealing with particular masses of a substance. And so moles can be calculated by dividing the mass in grams by the molar mass of that species. So you can use this formula triangle and rearrange to be able to find mass or MR depending on what you need to calculate for that particular question. So for our first worked example, how many moles in 80.6 grams of magnesium oxide? The mass from the question is 80.6 grams. The MR is 24.3 for magnesium plus 16 for oxygen to give 40.3 grams per mole. And so moles equals 80.6 over 40.3, which is 2.00 moles. Answer given to 3 significant figures, as that's the precision given to us in the question itself. For our second worked example, 6 moles of an unknown element has a mass of 390 grams. What element is it? To determine the identity of the element, we'll be calculating the MR as mass divided by moles. That gives us 65 grams per mole. And so looking at our periodic table, the element that best matches that is zinc. And finally, calculate the number of CO2 molecules in 11.0 grams. First, calculating moles as mass over MR, but we need the number of molecules. Molecules equals moles multiplied by Avogadro's constant, so 0.25 multiplied by 6.02 times 10 to the 23, giving us 1.51 times 10 to the 23 molecules of CO2. So it's your turn to have a go at some of these yourself. All of the relative atomic mass values that you need are over on the right. Pause the video now and press play when you're ready with your answers. For our first question, nice and straightforward, calculate the number of moles of methane in 42.0 grams. Moles equals mass over MR, so that gives us 2.63 moles. For our next question, the mass of 0.475 moles of calcium arsenate. First, we are calculating the MR by adding the individual relative atomic masses together, multiplying the MR by moles to give us 189 grams. For our next question, how many carbon atoms in 72.5 grams of graphite? First, similar to our carbon dioxide question earlier, we calculate our moles as mass over MR, which gives us 6.04 moles. But to find the number of atoms, multiply that value by Avogadro's constant to give you 3.64 times 10 to the 24 atoms. Now, in the calculator, it didn't quite say 6.04, but that's what I'm going to write down in the interest of saving some time, but I'm going to keep that whole number in my calculator to make sure that the final answer is as accurate as possible. And for our final question, how many moles of chloride ions in 0.75 grams of copper 2 chloride? First, calculate the moles of copper 2 chloride as mass over MR, and then moles equals 0.75 divided by 134.5, so 5.58 times 10 to the power of minus 3. In every copper chloride formula unit, there are 2 chloride ions. So we have to multiply our moles of copper chloride by 2 to find our moles of chloride. So that gives us a final answer of 1.1 times 10 to the power of minus 2 moles. So how did you do? Let me know in the comments below if there's anything you need explained a bit further. If you want a full lesson on calculating molar mass, let me know, and I will see you next time for another Miss T tutorial. Bye.